For problems 11 through 13, we're going to write the equation that represents the following transformations. Again, as a reminder, we do need to know what each part of the general sine-cosine equation looks like. Your A is your amplitude. B is the number of cycles. This is not the same thing as the period. The period is 2 pi over B. H is your horizontal shift, and K is your vertical shift. So number 11, a sine function with an amplitude of 3 units. Right away, A equals 3. A period of 4 pi. Okay. Let me pause here and go back to the period equals 2 pi over B. We can also use B equals 2 pi over the period to go back and forth between period and B value, whatever it is that you know. And so knowing that our period is 4 pi, we can say that B is equal to 2 pi over the period, which is 2 pi over 4 pi. And then if we simplify that, that's going to give us our B value. So these pi's cancel out, and 2 over 4 reduces to 1/2. So B equals 1/2. Shifted left, pi over 2 units. Left is negative. So our H is negative pi over 2. There's no mention of a midline or anything, so we don't have to worry about K. But our equation, and again, this is a sine function, that's going to be y equals 3 sine 1/2 times parentheses x minus negative pi over 2, close both parentheses, and that double negative inside the parentheses does change to positive, like that. So there's our equation for number 11. Y equals 3 sine 1/2 times x plus pi over 2. Okay, for number 12. A cosine function that has been reflected over the x-axis. So our A is -1. Then shifted right pi over 3 units. That's a positive H value. And has a midline at y equals 3. That's our K value. There's no mention of the period or anything here, so we can assume that our period is 2 pi and that our B value is just going to be 1. That equation would be y equals negative cosine of x minus pi over 3 plus 3. Okay, and then for number 13, we're given a graph. So we have to pick, first of all, whether we're going to use sine as a reference or cosine as a reference. And then from there, find the different parts of the graph to create the equation. Let's say we're using sine. I could look at this part of the graph, this one cycle of sine. Okay, our midline is at 0. The length of one cycle, let's see, halfway between 0 and pi over 2 would be pi over 4. And this point right here would be at 5 pi over 4. From pi over 4 to 5 pi over 4, that difference is just pi. b is equal to 2 pi over the period. So 2 pi over pi would simplify to 2. Okay, so b is 2. Our amplitude, this distance right here, this height would be 2. And our horizontal shift, okay, that distance that we've shifted right from the y-axis would be pi over 4. So that creates the equation y equals 2 sine 2 parentheses x minus pi over 4 close parentheses. Okay, that's, again, one option. If it makes more sense to you to use cosine, then let's relook at this in a different way. We'll highlight a different part of the graph. Here's one cycle of the cosine function. Notice that our midline is still at 0. Our period is still pi, so that b value stays the same. B is still 2. Our amplitude is still just positive 2, but our horizontal shift is different. That horizontal shift is pi over 2. It's been shifted further to the right as compared to the sine wave. So that equation would be y equals 2 cosine 2 times x minus pi over 2. Okay, so either one of these equations is correct. There's also other options. Say you're looking at this section of the graph, that would work. That would be another cosine equation, or you could look at this part maybe. Just know that these two equations are not the only correct answers. So if you came up with something else, I'm happy to check your work.